All right, welcome to day number 6, which is modeling, aka word problems. So today we're going to be doing some word problems and graphing of our trig functions. So we're going to review the parts of our equations just like we did with our last video when we were doing equations from a graph, and then we're going to do a couple examples. This is very similar to making an equation from a graph. The only difference is instead of being given the graph, you have to make the graph on your own using the stuff in the word problem. All right, so amps it up a little bit, but it's very similar to making the equation from the graph. Okay, here we go. All right, so graphing word problems and making an equation. So like I said, this is very similar to what we did last class where you were given the graph and you had to then make the equation, right? So the only difference here is that we need to use the information given to us in the word problem in order to make the graph, and then from there we can make the equation. All right, so I just wanted to write again our equation. I don't know why I left so much space up here. We're not really writing that much up there. All right, so just remember again, this is our standard like transformation equation. So we have y equals a sine or cosine, all right, b x minus c plus d, all right, where b is our frequency and our period equals, so the period equals either 2 pi or 360 divided by the b value. Okay, so we've written this many times, and like I said, you could also have it be cosine. All right, it's the same equation though, so I'm not going to write it twice. Plus, I just used up all the space. Okay, so we're just going to do two examples together. So we have one example, two examples, and I think that hopefully it's not too bad. Okay, so just like any word problem, you have to know how to pull out the information that's important. Okay, so at the beginning it says, when you ride a Ferris wheel, your height h in feet from the ground varies sinusoidally with time t. Sinusoidally is just a type of graph. It just means it varies like a wave. So sinusoidal, right, is what they call cosine and sine functions. So sinusoidal does not mean it's a sine function. It's just a term used to classify sine and cosine graphs. It's the shape that they make. So sinusoidal means it bounces up and down, back and forth evenly forever and always. Okay, so we're writing this Ferris wheel that has a diameter of 40 feet. So I'm not the best artist, so we're not going to judge Miss Lastly too harshly. So, oops, I don't want that. I want it to be a pen. So here's my Ferris wheel. I know it looks really terrible. We're just not going to judge it, okay? We're just not going to judge it. All right, and here's the center of my Ferris wheel. Okay, it says that our diameter is 40 feet. Okay, so diameter. We know we all took geometry. We know diameter is the distance across, right, from one through the middle and all the way to the outside. The diameter goes through the center of the circle. So this is our diameter. All right, and it equals 40 feet. Okay, which means that if the diameter is 40 feet, we know that the radius, which is just halfway, is equal to 20 feet, right? It's half. Okay. Next, it tells us that the axle, which is the center, it's that center piece right here, the middle, is 25 feet above the ground. So this is 25 feet above the ground. Cool. All right. So now what we're going to do is we're going to try and sketch this. So this is kind of a vague one. It's not my favorite problem to do first, but it's okay. All right. So if this right here is 20, right? That's my radius. And all the way to the ground is an extra 25 feet. Then I know I'm a total, right? So at my highest point right here from the ground, all right? So my highest point from the ground is 20 plus 25, so 45 feet from the ground. That's my highest point. So over here on my graph, let me move my head. There we go. I'll go float up. Oh no, I'm going to block stuff. I'm just going to make me smaller. It's fine. You don't need to see me. I'm not that relevant. Okay, so my highest point that I hit is going to be 45 feet. Okay. All right. Now, the lowest point, so when we're riding this Ferris wheel, we're never going to actually hit the ground. That would be bad. That would mean the Ferris wheel broke. All right. So the lowest we're going to go on the Ferris wheel is this bottom point right here, right? So we know that if the highest point is 45, we can find our lowest point by doing a little bit of subtraction, right? So highest is 45, okay? I know that this, right, is 40 feet, the whole, like my diameter, all right? So if I do 45 subtract 40, that tells me that my lowest point I'm gonna be is 5 feet above the ground. So 45 feet above the ground is my highest, 5 feet above the ground is my lowest. All right, so that's highest, lowest point of my Ferris wheel. All right, next, I need my midline. So I need to know where the middle is. Okay, so I need to figure out what is in between 45 and 5. So just like we did it on our problems the last time, we're going to take 45, subtract 5, and then divide by 2, right? We're finding the midpoint. All right, so halfway between 45 and 5. Oh, no, we are going to add it. Are we going to add it or are we going to subtract it? We're going to subtract it. Yeah, we want the difference, and then we want to divide that by 2. Yes, yes. No, we're going to add. We add. That makes more sense. That's, yeah. Add the 2, divide by 2. That's how you find the average. I don't know what I'm thinking. To find an average, you add the 2 numbers, you divide by 2, that gives you the middle. All right, so this is 50 divided by 2, which is 25. So my midline, 25 feet. Cool. So I've set up my y-axis. Now I need to set up my x-axis. All right, so let's see what else it gives me in the problem. So I used this first line to figure out my y values, my height. All right, so next it says, blah, 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 blah. If you reach the highest point after 20 seconds, and if the Ferris wheel does 2 full revolutions every 5 minutes, write an equation that would represent this situation, find the indicated values. Okay, so after 20 seconds, I hit my highest point. Okay, now there's obviously points that come before that, but I don't know them. All I know is I hit the highest point after 20 seconds. So on my x-axis, 20 seconds, I have 45 feet. All right, it does 2 full revolutions every 5 minutes. Well, I don't care about 2 full revolutions. I care about 1 revolution. So if it does 2 revolutions in 5 minutes, then it does 1 revolution in 2.5 minutes, right? So 5 minutes divided by 2 is 2.5 minutes. All right, ooh, it's off to the side there. We'll just zoom out a little bit. Zoom, zoom. All right. So 2.5 minutes. Okay, so just one more time. 5 minutes for 2 revolutions. So 2.5 minutes for 1 revolution. All right, and 2.5 minutes. So since we're doing this in seconds, I'm going to convert 2.5 minutes to seconds. All right, so that's 2 minutes times 60 seconds plus 1/2 times 60 seconds. You don't have to do it like that. That was just what made sense in my brain at the time. You can do it however you want. Plus 0.5 times 60. So this is 150 seconds. This is my period. Okay, so that's how long it takes me to do 1 full revolution around the Ferris wheel. That's a really fast Ferris wheel. You're like zooming around that thing. Okay, so that means my ending point, all right, is 150 seconds after my starting point. So plus 150 seconds. So 20 plus 150 is 170 seconds. That's my next time I'm going to be back at my highest value. All right. So now I need to figure out my other things. We know that trig graphs always have a total of 5 points. I have 2. I need to find all 3. All right. So what you can do is you take your period, right? We've done this before. Take your period of 150 and then divide it by 4, right? Because we're moving, right, evenly between these things, right? We have 4 places to move. Starting from the first one, we move 4 times to get to the 170. So we're going to do 150. We're going to divide it by 4. And 150 divided by 4 is 37.5. So I'm going to add 37.5 each time to get to my next point, just like we do with all of our other ones. All right, so 20 plus 37.5, that's 57.5. All right, so this is 57.5 plus 37.5, that's 95, plus 37.5, that's 132.5. And if we add it one more time, it should give us 170, and it does. Okay, so now I have my x-axis filled out. So the only thing left to do is to go through and put my other points. So I have my starting point and my ending point. All right, I know that in the middle, it's going to be down at 0, or down at the minimum, sorry, not at 0, down at the minimum. And then right here, it's going to cross through my midline. That's just because I know that trig functions that start high have the middle point in the middle, and it crosses the midline. So then I sketch my graph. Okay, so I'm getting closer. All right, so I'm going to go over here. I have my graph. All right, so I now officially have my graph for my function. All right, I don't need this piece anymore. That was just to get my y values, right? Now I just need this part, so I'm just going to move it over. There we go. Move it over, do a little shrinkage. Technology is great sometimes. There we go. Okay, so I have my graph. There it is. All right, now I can go through and I can find all my different values. So my amplitude, all right, that's the distance between my highest point and my midline. That's 20. My midline is y equals 25. My frequency, so I haven't found that yet, so we'll come back to that in a second. But I do have a period. My period is 150 seconds. All right, my phase shift, that's where we're starting. So the first point that they gave me was after 20 seconds. So my phase shift is to the right, 20 seconds. Okay, now I need that frequency piece. So just like we did in our last video, to find our frequency, which is our B value, all right, we take 2 pi or 360. Now this is a word problem, so it doesn't matter if you do degrees or radians, you get to pick. I'm gonna do degrees, why not? So 360 divided by my period of 150. So 360 divided by 150 is 2.4. All right, so my frequency is 2.4 degrees. Just kind of ugly, right? And I have to leave the degrees because they don't cancel out, right? Because 360 has a degree, but 150 is seconds. So I have to leave that degree symbol. So 2.4 degrees is my frequency. Now we can also do this probably as a fraction would be better, right? This is 12 over 5 degrees. Okay, so to make our equation, all right, we're almost there. Last thing we need to do is look at our graph and figure out what type of trig function that is. It starts high, ends high, has the shape of a C, that's a cosine graph. All right, so this is going to be y equals, and it's a positive cosine because it starts at the max. So y equals 20 cosine, parentheses, 12/5 degrees, or you can do 2.4 degrees. I don't mind a decimal here. All right, hold on. I moved this too close. There, we're just going to go that way. So there we go. Okay. All right, degrees, parentheses, x minus 20, close, and then plus 25. I'm just going to write this. I ran out of space. It's okay. Y equals 20 cosine, parentheses, 12/5 degrees, x minus 20 plus 25. There's my equation. All right, so now we're going to do our second one. So it's a little bit different, right? It doesn't have the whole Ferris wheel thing. Bloop, 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 bloop. Okay, so it says, John is floating on a tube in a wave tank. At t equals 1 second, John reaches a maximum height of 14. All right, so we're going to go ahead and we're going to just sketch this out. Okay, so this is a wave tank. So here's the water right at the top. All right, so it says he reaches a, well, that's probably not the right where the water should go. The water should be like he's riding on the water. He's not like underneath the water. I'm not going to try and draw the water. All right, so we have a maximum height. We have a maximum height of 14 meters. All right, above the bottom of the pool. So like here's the bottom of the pool. Bottom of pool. There we go. And he's like riding on the water, right? Okay. So, then it says that he's at this maximum height at 1 second. So 1 second. He's at this maximum height. So we have this point so far on our graph. All right, then it says at t equals 9 seconds, John reaches a minimum height of 2. So we know that 2 is our minimum, and we know that after 9 seconds, he reaches that minimum value. So we have this point right here. All right, and that's all it gives us. So then it just says, sketch a graph that represents John's height from the bottom of the pool with respect to time. Okay, so it didn't actually give us very much information. So it didn't tell us how often he does, like the last one told us it does a revolution every, 5 minutes or whatever. We don't have that. We only have this. This is it. All right, so we have to know a little bit about our trig graphs. Okay, so we have a max point and we have a min point. All right, now, in order to do a full cycle, we have to somehow end up back at this maximum point. All right, so we need to figure out when would that be. So to do that, what we're going to have to do is figure out how much is in between 1 and 9, and then that's the same amount that's going to be between 9 and our next highest point, because trig graphs are always even. All right, so all right, so 1 to 9, that's 8. We moved 8 spaces. So that means there's going to be 8, 9 plus 8 to give us our next point. So 9 plus 8 is 17. All right, so my next point is at 17 seconds. All right, so that's important. We needed that. All right, now we also need to figure out what our midline is. So our midline is going to be this line right here. So we need to figure out what point is between 14 and 2. So we add and then we divide by 2. So 14 plus 2 divided by 2, that's 16 divided by 2, that is 8. Yes, I think so. Yes, I was just double checking. It didn't seem right for a sec. I don't know why. All right, so that's our midline. All right. Now we need to figure out our other x-axis points. So we're going to have these points here where it crosses that midline. All right, so I need to figure out what's between 1 and 9. All right, so again, we can just do an average. We add 1 plus 9 and then divide by 2. That's going to be 5. All right, now a couple ways you can do this. You could do the midpoint between 9 and 17, right? You could do 9 plus 17 divide by 2 to figure out what's in between them. So what, 9 plus 17 divided by 2, that's 13. All right, and then to double check, what you would do is just, these points should all be evenly spaced. All right, so if you subtract 5 and 1, you get 4, right? There's 4 in between right here. Oops. That's plus 4. All of these other ones should also be plus 4. If they're not, then something has gone wrong. All right, but 1 plus 4 does give me 5. 5 plus 4 gives me 9. 9 plus 4 is 13. 13 plus 4 is 17. So that does work out. That is correct. So I have my points spaced nice and evenly apart. So those are my x-axis values. All right, so now I connect my dots. And that is the graph of my function. All right, the next question wants me to make the equation. All right, so it's always good to kind of list out all of your pieces, C and D. All right, so we're gonna go through and we're gonna find everything. All right, so our amplitude, that's our highest point to our midline. All right, so what's between 14 and 8? So subtract 14 minus 8, that's 6. Just double checking, 8 and 2, 8 minus 2, that's also 6. So I have an amplitude of 6. My B value, so to find my B value, it's, we'll do radians this time. So we'll do 2 pi divided by my period. All right, the period is how long it takes us to go one full cycle. So from highest point to highest point. So that's 17 minus 1, right? The distance between those two. So subtract 17 minus 1. So that gives me 16. So I have a period of 16. So to my B value is 2 pi divided by 16, which is going to simplify to pi over 8. So B is pi over 8. C value, that's my starting point. So I take my first point that I have and I look to see how far over it is from 0. It's 1. So my C value is 1. All right, and then my D value is my midline, and we already calculated that. That midline is at y equals 8. So 8 is my D value. So now I can make my equation. It is y equals, one last thing, we need to look at our graph. So going from highest point to other highest point, all right, start to finish, that is a cosine graph. So I need to make sure that I use cosine for my equation. So y equals 6 cosine, parentheses, pi over 8, parentheses, x minus 1 plus 8. Okay, last question says, what is John's height from the bottom of the pool at 21 seconds? All right, so remember, seconds is what goes on the bottom of our graph. So right here, these are all seconds. All right, so seconds is an x value. So all I need to do, so this is an x value, is plug 21 into my equation for x and solve for y. So I have y equals 6 cosine pi over 8, 21 minus 1 plus 8. Now, we did this in radians, so when we go to our calculator, we want to go to mode, and we want to make sure that the radians button is selected because we are doing this in radians, right? If we were doing this in degree, we would want to make sure we were in degree mode. All right, so all we have to do is type this exactly in as you see it. So 6 cosine, hit the pi button, divided by 8, parentheses, 21 minus 1, close parentheses, plus 8, hit enter, and I got 8. All right, so what is John's height from the bottom of the pool at 21 seconds? It is 8 meters, right? Because we were measuring